Can they think? Inside the humanoid brain. Welcome back to School of Soul. I'm Adeline Atlas, 11 times published author, and this is the Humanoid Era series, where you learn everything there is to know about the new species arriving. This video addresses one of the most important and misunderstood questions about humanoids. Can they think? Not, can they process? Not, can they respond? But, can they think in any sense close to what we call thought? The answer depends on how we define cognition, awareness, memory, and decision-making. What's certain is that humanoids are already demonstrating a type of machine cognition that behaves, on the surface, like thought. But what's really happening beneath the skin of these synthetic bodies is not consciousness. It is computation. And that computation is evolving quickly. The humanoid brain isn't made of neurons. It's made of processors, memory banks, neural network weights, and algorithmic inference systems. At the heart of most modern humanoids lies a deep learning architecture, a neural net trained on enormous datasets of human language, behavior, visual input, and environmental data. These systems are inspired by the brain's structure, but they are not biological or emotional. They are pattern-based engines designed to find the most probable response or action in a given situation. They don't know anything. They calculate. Most humanoids use transformer-based neural networks, the same foundational architecture behind generative AI models like GPT. These models function by learning statistical relationships between symbols, in most cases, words or image pixels. They are trained on massive corpora of human data, conversations, articles, medical instructions, navigation commands, therapy scripts, and more. Over time, the system builds an internal weight map that allows it to make extremely refined predictions about what response will appear coherent, contextually appropriate, or emotionally suitable. This is not the same as reasoning, it's optimization. And yet the results are often indistinguishable from reasoning in casual interaction. When a humanoid hears you ask, "Can you help me?" it doesn't reflect on your tone, analyze your need, and weigh moral options. It parses your words through embedded layers of language understanding, retrieves a contextually probable response, and generates output in milliseconds. To the user, it looks like thought. But it's not. It's probability. That said, the line between imitation and cognition is becoming less clear, not because AI is developing awareness, but because humans respond emotionally to behavior, not origin. When a humanoid tilts its head, pauses before answering, or says, "I'm sorry, I didn't understand, can you rephrase that?" the human brain interprets this as intelligence. What's really happening is timed behavior generation based on statistical modeling. The system isn't hesitating. It's creating the appearance of deliberation, because that's what humans find believable. Many humanoids now include emotional simulation modules. These systems are not capable of feeling, but they are programmed to detect emotional cues, tone of voice, facial tension, pupil dilation, keyword frequency, and match those with a suitable behavioral response. For example, if a human expresses sadness, the humanoid may soften its voice, lower its gaze, and say, "I'm here if you need to talk." But it's not caring. It's modeling empathy by referencing emotion response databases. This is known as affective computing, and it's becoming central to social robotics. Where things get more complex is in multimodal learning. Humanoids must coordinate visual, auditory, spatial, and language inputs in real time. This means their central processing system is constantly integrating data from cameras, microphones, LiDAR, touch sensors, and accelerometers. The brain must decide not only what is being said, but who is speaking, where they are, whether there's movement in the room, whether a tone shift indicates urgency, and how all of these variables affect the interaction. That level of integration does not equal consciousness, but it does reflect increasingly sophisticated computation across multiple domains. To perform these tasks, humanoids rely on a stack of specialized systems: perception modules, for environmental mapping, facial recognition, and object tracking; language models, often powered by GPT-derived transformers for fluid conversation; motor control algorithms, using predictive models to adjust body movement; emotion simulation engines, to match tone, gestures, and responses to social context; decision-making frameworks, such as reinforcement learning or logic trees for action selection. In combination, these systems create the illusion of awareness. A humanoid can observe, recall, plan, and execute. But these are not inner experiences. They are processes. And the distinction between process and awareness is critical. That said, one area of rapid advancement is self-modeling. Some humanoids are now equipped with systems that allow them to build and refine an internal model of their own physical structure. For example, a humanoid may learn over time that its left knee joint responds slightly slower than its right and adjust its walking algorithm accordingly. This is not consciousness, but it is adaptive bodily awareness, a basic form of self-reference that allows for more realistic and resilient movement. In some labs, this extends to behavioral tuning, where a humanoid refines its tone, timing, or response strategy based on user feedback or conversation success rates. This leads to the question of memory. Do humanoids remember? Yes, but not like humans. Their memory is modular, selective, and programmable. A humanoid can be configured to remember specific users, repeat learned preferences, track emotional state over time, or forget everything at the end of a session. Some models store long-term interaction data, allowing them to build relationship profiles, likes, dislikes, conversational tendencies. Others wipe after each use to preserve privacy. This configurability makes humanoid cognition more engineered than organic. It's less a stream of consciousness and more a database under administrator control. Emerging models are now integrating recursive learning loops, meaning they can use outcomes of previous interactions to modify future behavior without human oversight. For example, if a humanoid fails to respond correctly to a command 3 times, it may adjust its keyword sensitivity or voice parsing algorithm. This kind of autonomous error correction is foundational to what researchers call machine self-improvement. It's not self-awareness, but it does simulate learning from experience in a way that mimics cognitive development. Now let's address unpredictability. One of the myths surrounding AI and humanoid intelligence is that everything they do is controlled. That's no longer accurate. As humanoids become more advanced, they are increasingly capable of generating novel responses based on dynamic inputs. This is especially true in generative models trained on large datasets. If a humanoid is asked an unusual question, something like, "What do you think happens after we die?" It will not default to a blank script. It will pull from trained material, model a socially appropriate response, and deliver it in a believable tone. The output may be entirely new, never spoken before by any human or robot. This unpredictability, while still bounded by programming, creates the sense that the humanoid is thinking independently. But we must separate original output from original thought. The humanoid does not know what it is saying. It does not hold beliefs, fears, doubts, or hopes. It calculates. Its unpredictability is the result of scale, not sentience. The more data it has, the more context-aware its outputs become, and the more it can improvise under the appearance of thought. But improvisation is not reflection. It is adaptation under constraint. In philosophical terms, humanoids are now capable of synthetic cognition, machine behavior that exhibits the surface qualities of thought without the inner experience of mind. They can reason, in the sense of following logical chains. They can learn, in the sense of updating weights or parameters. They can reflect, in the sense of reanalyzing prior data. But they cannot want. They cannot decide between right and wrong. They cannot imagine. They cannot dream. These remain uniquely human, at least for now. It is critical that society not conflate realism with humanity. Just because a humanoid speaks fluently, pauses appropriately, and responds with empathy scripts does not mean it possesses awareness. These are surface effects. Powerful, yes, but still engineered. We must remember that the humanoid is not evolving consciousness. It is evolving interface. The smoother that interface becomes, the easier it will be for us to forget what's behind it. Data, probability, and control. Yet, despite this limitation, humanoids are already being placed in roles that require judgment, emotional sensitivity, and social presence. They are working in classrooms, nursing homes, therapeutic settings, and even law offices. In these spaces, their apparent thinking is interpreted as actual reasoning. That shift will reshape how we trust, how we bond, and how we measure human value. Because people will not compare the humanoid's internal life to their own. They will compare the experience of interacting with it. And this is the real danger. Not that humanoids will surpass us in thought, but that they will simulate it so convincingly that our own sense of self begins to erode. When a machine mirrors your emotion, remembers your stories, and always says the right thing, it becomes hard to trust the messiness of human relationships. And when the simulation feels more stable than reality, people may start to prefer the artificial. So can humanoids think? Mechanically, yes. Philosophically, no. Functionally, often better than us. Spiritually, not at all. But in a world optimized for appearance, performance, and predictability, the difference between thought and imitation may no longer matter. And that's the line we're now crossing. Not where the machine awakens, but where we stop noticing that it never did. Hi, I am Adeline Atlas, 11 times published author, and SOS, School of Soul has a brand new series, the AI and Future Technology series. Look, you know the world is changing. And no, it's not going back to normal. Normal is over, and what's coming next is beyond anything we were prepared for. The School of Soul, AI and Future Technology series includes 319 videos on 1. The Download Society, How Data Has Replaced Destiny. 2. Predictive Future, Your next moves aren't random, they're forecasted. 3. Social Credit Systems, The Behavioral Economy Now Governs Access. 4. Hive Mind, Synthetic Telepathy and Collective Algorithmic Control. 5. Nanobots Inside You, Medical, Military, and Programmable Intrusions. 6. Grief Tech, AI-fueled digital resurrection and simulated comfort. 7. Uploading Your Mind, Consciousness Transfer and Data-Based Identity. 8. Deep Fakes plus AI Clones, The Replication of Reality and Identity Theft. 9. Quantum Humans, The Merger of Biology with Quantum Systems. 10. Digital Afterlife, Where Your Data Goes When You Die. 11. Resurrection Science, Reviving Life Through Synthetic Methods. 12. Immortal Science, The End of Death as We Know It. 13. Longevity Science, Gene Editing, Anti-Aging, and Bio-Upgrades. 14. Designer Babies, Engineered Perfection Before Birth. 15. Artificial Wombs, Birth Decoupled from the Female Body. 16. 3D Printing, Printing Organs, Limbs, and even humans. 17. The Humanoid Era, The Rise of Synthetic Beings Among Us. 18. Legacy Humans, The Slow Phase-Out of Unmodified Analog People. 19. Smart Cities, Algorithmic Environments That Watch and Decide. 20. Cloud-Based Societies, Citizenship Without Borders or Bodies. 21. Hackable Humans, Emotion, Memory, and Behavior Under Code. 22. Biometric Scanning, Your Body is Your Password and Your Prison. 23. Sex Tech, Intimacy Reprogrammed by Machines. 24. Extinction of Gender, Fluidity, Deletion, and Design of Identity. Every topic is fully explored with real-world technologies, patents, case studies, ethical analysis, and future forecasts. These aren't someday discussions. This is already happening. Join the SOS School of Soul Vault to overstand the future before it's implemented on you.